Okay, Algebra 2 students, here's a video for example 3 for section 3.5. We're going to find the real and complex zeros. What are all the real and complex zero of the polynomial function shown in the graph? Here it is. We can see there's one zero, a real zero, at 2. But they don't show us, because it's got an exponent of 3, there's 3 zeros, but they only show us one of them. So the other two must be imaginary. Let's see how they do that. We have 2, it looks like it's 2, so they plugged in a 2 just to confirm that it turns out to be 0. When you plug in 2, you yield a result of 0, so yes, that confirms that x minus 2 is a factor, and that 2 is one of the roots. Okay, and now that we know that 2 is one of the roots, we're going to substitute that in, we're going to use synthetic division. Okay, we haven't done this one. We've done synthetic division before, but we haven't done what we're about to do. When we plug in a 2, it comes out to 1, 3, 3, 0. 0 is the remainder. And if you recall from a section or two ago, this 1, 3, and 3 represents the coefficients of a trinomial 1x squared plus 3x plus 3. That's where the 1, 3, and 3 go as coefficients. And that means the function f of x can be broken down into x minus 2 times x squared plus 3x plus 3. The reason why I want to do that is we want to reduce it to a trinomial, a quadratic. So now we can use, let's see which method they use. They use the quadratic formula for this blue. A is 1, B is 3, C is 3. They plugged into the quadratic formula, which we learned in an earlier section, and they came out with the two roots, negative 3 over 2 plus or minus the square root of 3 over 2i. So it turns out the three zeros, because it has x cubed, so we knew there were 3 zeros, were 2, and that was from inspection, plus we tested it out, and then the 2 imaginary ones. Okay? Let's see if they give us another practice problem. Sure. Same thing. It's a cubic function, so we can go by inspection and see that it crosses at 3. Oh, this is a try it. Right. So go ahead and try this, and then come on back when you're ready. I'm going to plug 3 into synthetic substitution and reduce this and see what I get. So let's see right here. I'll plug in a 3, and hopefully it comes out to 0 as a root. I have 2x cubed minus 8x squared plus 9x and a minus 9. So it's the synthetic division. Let's see, bring down the 2. 2 times 3 is 6. 6 plus negative 8 is negative 2. Negative 2 times 3 is negative 6. Negative 6 plus 9 is positive 3. 3 times 3 is 9. And yes, it does come out to 0. So that means 3 is one of the roots. We don't want to forget that. And now we have the coefficients of the quadratic. I'm not going to write it in here because you really only need to know that. Let me change colors for effect. You really only need to know that A is this, and B is this, and C is this. And then you can plug it into the quadratic formula. Okay? Plug it into the quadratic formula and see what you get for the 2 imaginary roots. Let's see what you should get. I'm not going to do that out, but we did quadratic formula a while ago. You get 3 and 1 plus or minus I squared roots of 5 over 2. That's funny. They wrote it differently than they did the other time. The other time they wrote it as 1 over 2 plus or minus I squared roots of 5 over 2. Either way, there's your 2 imaginary roots. There's your 1 real root. They give us another one to try. This one here, a quartic function. It's got to the power of 4, but I can see only 2 of the zeros. I don't know what the other 2 zeros are, but I know it looks like negative 2 and 2 are 2 of the zeros, so I'm going to use that. We haven't had one that's quartic yet, so you may want to watch me do it. I'm going to take one of the roots, which is negative 2. I'm going to plug that in. Synthetic substitution. I have 1x to the 4th. I have 0x cubed. I have negative 3x squared. I have 0 x's and -4 for the constant. Okay, when I plug in -2, let's see what I get for a result. I should get 0. 1 comes down. 1 times -2 is -2. -2 plus 0 is -2. -2 times -2 is +4. 4 plus -3 is 1. 1 times -2 is -2. -2 plus 0 is -2. -2 times -2 is +4. And yes, -4 plus 4 comes out to 0. Excellent. So we know one of the roots is confirmed to be -2. Now we think the other root is 2. So I'm going to take this remainder right here, or not remainder, I'm going to take these coefficients and I'm going to test out to see if 2 goes into those. Okay? Bring down the 1. 1 times 2 is 2. 2 plus -2 is 0. 0 times 2 is 0. 1 plus 0 is 1. 1 times 2 is 2. -2 plus 2 is 0. So yes, it did come out. And now you could use the quadratic formula knowing this is 1x squared plus 0 plus 1. But because I'm going to use a different method. Oh, we already know 2 is one of the roots. I'm going to use a different method. This essentially comes down in that x squared plus 1 is the other factor. I'm going to set that equal to 0 and solve. I'm going to solve with a concept we learned earlier in the chapter. I'm going to subtract 1 from both sides. That's going to give me x squared equals -1. I really hate how this pen works with my mouse. Let's see if I can make that come out better. Take the square root of both sides, and I get x equals positive or negative square root of 1, a square root of -1. And the square root of -1 is I, so I'm really getting, these are 2 of the roots, and the other 2 roots are positive and negative I. All right, let's see what they got. -2 and 2, positive and negative I. All right, hopefully that gives you enough information to be able to handle these problems. Oh, there's only 3 problems. 9, 17, and 28. That's it for this video. Have a great day.